coordination and commitment to work safely. We've got people that are going to be coming in and working through the night in order for, because we're taking some of the power down in order for you all to get your work, start your work done in the morning. So we've got fatigue issues, we've got stress issues, and there's always something that's going to happen unexpectedly, and all of that can roll up, which gives us a potential for having a bad day. And speaking of bad days, can I ask all of the qualified electrical workers to stand up? Okay. What ship is that? Anyone of you who are standing want to tell me?
The HMS Dipole.
No. John? You don't know it? Does anybody? Any of you know it? It's the ship that sank in the hurricane, and does anyone remember the name? It's the Bounty. All right, Kevin, you answered the question. The rest of you can sit down because there's. What does the phrase "test before touch" mean to you?
Walk, pass, and try.
Oh yeah, but what does "test before touch" mean?
What's that?
What does "test before touch" mean to you?
Being safe and careful about it.
All right. Haven't hit it yet. Any of the qualified electrical workers?
Proving something is dead.
Proving something is dead before you touch it. Okay. Well, I'll give you the prize anyway, Kevin.
Thank you, Mr. President.
You just gave away the winning lottery ticket that was going to win you $777,777. Okay, so back to bad things happening and unexpected things happening. It's how we deal with those and how you deal with those things that are really going to get us through safely and through the down. So there's some commitments that I'd like you all to make, or recommitments on how you're going to work. And the first is to raise questions and concerns. And honestly, I'm saying recommitment because you already do that. In fact, our last safety culture survey that we just finished said 76% of you that responded in this room said that you feel comfortable doing that. You feel to do that, and you have done it. So for the 76% of you sitting here, great. Keep it up. We really need that. Hold on one second, Dave, before you start picking apart my numbers. Okay. For the 24% of you who didn't say you feel empowered, now's the time to step up. And frankly, if you feel concerned in that area that you can't feel empowered to step up, come talk to me. All right, Dave, you had a question?
I feel empowered. I feel empowered to tell Kevin that was a mistake to throw that. It went straight back and almost hit the camera.
Yeah.
All right, Dave. You win. Okay, so thank you, Dave, for raising that concern. We also want to make sure, we also want you to recommit to addressing unsafe behaviors and conditions as you're working. 88% of you have said that you feel comfortable doing this. You have done this both with yourself and your coworkers. Yay. You sitting in the back on the floor, please find a chair. Thank you. Oh, I missed one. Okay, and finally, you're going to have to make adjustments, and so I'm going to flip it. We always say if the plan changes or something happens, to step back and take a look at it and replan, and we know that and we repeat that. But the other part I want to make of this is, if you see a better way of doing things that's a safer way, bring it up, make those adjustments. In fact, in that survey, when we asked that question, do you feel empowered to make those kinds of changes? Only about 4% of you said you felt uncomfortable doing that kind of thing. So I encourage you, if you find a safer way to do something, let's go ahead and do it. If you have to replan it and do all that other stuff first, that's fine. But let's not stay so focused on the plan that we miss opportunities for doing things more safely. Okay, those are what I'm asking you all to commit to. And in return, your management is committed to those daily work coordination meetings. That's the place where there's issues involving safety, security, quality, conflicts, whatever. Bring those up. There will be people there, managers there, that can make those decisions quickly so that you can get to work and work safely. You're going to see your managers out in the field. You might even see some of them working. And finally, keep calm and stay focused. And remember that any decision that you make to stop your work because you have a concern about safety or quality will be supported without question. And again, if you run into a problem in this area, I'm at 7447. So with that, I'll turn it over to Dave, who probably everyone's been waiting for.
There was an idea to bring together a group of remarkable people,
to see if we could become something more.
So when they needed us, we could fight the battles
that they never could.
Check. Before we step into the more serious information, and with this compressed SAD, we really still are having radiological issues unfold with the 12-JEV error. We really need to be unified, much like the Avengers, as we safely address the tasks associated with the accelerator SAD. So in the time I have before you, we're going to address these topics to try to get you thinking about the work that you have to plan and execute during the SAD, because we really need you to be thinking as you're scheduling. There's a lot of new issues that you'll experience down in the tunnel. First up, postings. Really, they're an administrative control, but they are actually our first line of defense. All of our signs are designed to let folks know exactly what you need to know prior to entering an area. For example, radiologically controlled area, let you know you need a dosimetry required for entry. Contamination area, RWP required for entry. All of our signs try to leave nothing to chance, nothing in question. If you do have a question about any of our signs, please just call the RADCON cell phone, okay? Boundaries are established with a combination of signs, stanchions, and ropes. The boundaries represent a plane, so keep this in mind. All of the area above the ropes and beneath the ropes, that represents a plane, so we can't have folks reaching over a boundary to grab items or going beneath the rope to grab items, certainly with respect to contamination areas. I highlighted this picture because many of you will be working in the accelerator tunnel around the C100s. And you'll likely see this radiation area walkthrough permitted for several weeks to maybe even months. What this really just means is you can traverse the area, walk through there, but to perform work in these areas, you have to contact RADCON so we can schedule the work, okay? During the SAD, a lot of radioactive materials coming out of the tunnel. Remember, all items have to be surveyed prior to removal. You'll see these blue signs at all of the exits from the halls of beam enclosures to remind you that items that have been in the beam enclosure during operations have to be surveyed. Be careful when you're performing swaps, replacements, not to throw things or toss things in your tool bags and then they not get surveyed, because we really do need to survey and keep accountability of all items coming out of the tunnel. Items that are activated, they're designated with a RAM tag, so you should see this. Items that are for reuse, we call them SBR, Save for Beneficial Reuse. There must be a storage area adequate to receive those radioactive materials. So if you have radioactive items that you need to bring back to certain areas, if they're not already posted radioactive materials areas, we can work with you to do that, right? For large items, the CMSA is still available, although there are new protocols in place. Rusty may talk about that a little bit. You see there's a new access fence. So you really just need to coordinate with either facilities and or RADCON prior to moving items out of there. There are very few people that have keys to these gates, okay? Activated items that are no longer needed, they are considered RAD waste and they're managed by our RAD waste program. For large items, they're either typically staged for processing in the RADCON section of the experimental staging building or the RAD waste section of the CMSA. And again, you just need to coordinate with us prior to bringing things out there. Small items that are in the tunnel can either be tossed in one of our RAD waste trash cans or one of the RAD waste bins. These are staged throughout the beam enclosure, the halls. There's some in the test lab, in the TED, and even the EO building. Help us out by not throwing paper products, cardboard, cups, and even light bulbs in these bins. There are designated containers for those items, and we survey those out as well before they come up from the tunnel. A lot of items coming out for rework, preventive maintenance. Our RCTs perform rounds at least twice a day to accommodate your needs. But if you have some immediate needs, just give us a call. Please be patient. We'll get to you as soon as we can. We have some new RADCON survey required tags. These are for if you have an item down in the tunnel that you need surveyed, please just ensure you fill these out completely, your group name, your owner, your phone number. Items that are surveyed, if they're okay, we would put okay on the tag with the date to let you know, so when you come back you will see it. For the halls, we also have this okay tag that is affixed to items that are surveyed clean. And typically for the LINACs, the RCTs, if things are clean, they actually bring them up out of the tunnel. And with the help of Operations Steve and Cryo, who worked with us, we have these new storage carts that have been staged in the north and south LINACs. And each one of these drawers have a group designation, so INC, DC Power, all of those groups. So this kind of helps with housekeeping now. We used to survey stuff up and it would get left there. Some folks would call us and ask, where's our stuff, because somebody picked it up or whatever. So these are proven to be very successful. We have noticed also there's some components that need special assessment, cold cathode gauges, ion pumps with strong magnets. Some of these items, if you know you have them out, just give us a call so we can make sure that we have the proper instrumentation to survey them out. With all of the enclosures and restricted access, there's lots of opportunities for tours, so just ensure that you make the proper notifications to the area coordinators. Becky would throw something at me if I didn't say, please try to use the tour database. There's a tab on our the RADCON website to initiate a tour so that we can quickly process you if you have visitors. We provide dosimetry for visitors from 8 to 4:30, so just come over to the ESH&Q building and we will accommodate you. If you're an escort, just keep in mind that visitors, and we will have a lot of radiation areas, at least initially down in the tunnel, visitors cannot enter radiation areas or greater, and they must have an escort at all times. Okay, training, a lot of summer students coming in. We still have 3 areas to do the RAD worker training exam. If you're requaling or if you're taking it for the first time, CBAF Center, the user liaison office, I still call it the BARC building, but I think it's the SSC now. So that lets you know how long I've been here. And as well as the ESH&Q building, you can come there and have your test administered to you. For RAD Worker 1 practicals, that's SAF 801P. We administer practicals on Tuesdays and Thursdays at 2 p.m., and that's by appointment. We don't just do that every Tuesday and Thursday, so just give us a call, and we'll accommodate you, get you scheduled for a practical. And last, just a little bit of a refresher, all of these tasks require RADCON coordination. Just want to really highlight two in the middle, moving radioactive materials and disassembly of radioactive materials. All of our RAM is tracked when it comes out of the beam enclosure. We have a database so that we should be able to account for all of our RAM whenever it is. So if you have to move an item, you have to call us. We had a near miss recently in one of the halls where an item that was tagged as activated on the release tag was kind of swooped up with all of the rest of the OK tags. Fortunately, one of the RCTs caught it before it was moved out of the controlled area. But just be mindful, slow down, look at the tags, and ensure that we're staying on the same page. And again, disassembly of RAM, that's critical too, because if you have one piece of radioactive material and you just start taking it all apart, people can come by and want to grab pieces. We really need to know when you have to do that so we can account for all the pieces. Okay? Again, just coordinate all your activities with us. And if you have any questions, we're here to support you. And it's always better to call that number right there. I have it all the time. Thank you. Any questions?
Oh, Jonathan? Okay, good.
Go on? Okay. All right.
Just this to purpose, and then the laser is the green.
Okay. Awesome. All right, so good morning. So I was asked to say just a few words. It said on the list that I was talking for engineering, but basically I'm talking about cryogenics and some facilities work during the engineering, within the engineering complex. So basically, let me zip down through here and get started. So as y'all know, we're going to be putting our plants into a different configuration for the summer. We have 5 cryogenic plants on site, and for the summer, we're going to take the central helium liquefier number 1 to room temperature. So we're going to shut that plant down and we're going to warm it up. We're going to leave CHL2 running, and it will switch between 2K and 4K during different times of the summer to support different activities that the LINACs need to do. And we're going to connect this plant to both LINACs. So instead of one LINAC being on this one and one being on this one, they're both going to be on this LINAC for the summer. I mean, this refrigerator for the summer. We're also going to shut down the in-station refrigerator, and we're going to warm it to room temperature so that we can do some work down there. But we plan to make LN2 available to the halls and recovery systems available to the halls for most of the summer. There's some short outages of things like the recovery compressors because of power work that facilities is going to be doing, but we're trying to manage those to keep them small. The Hall D refrigerator is going to be operating at 4.5 Kelvin like it normally does and supporting the magnet. Now, a lot of times y'all know, everybody says, oh, cryo's doing YouTube operations. Cryo's doing YouTube operations. Well, this summer, just to give you a picture of what that means, we're going to be doing 16 YouTube operations at CHL. We're going to be doing around 40 of them at the ESR and about 48 of them in the tunnel. And so this sort of activity takes a lot of people, a lot of planning, and it's moving all of these YouTubes to various other configurations so that work can be done. So this is a huge effort for our people, and we have to do it very safely. It has to be planned out very safely. So I'm not going to go through a long, exhaustive list of all of the stuff that Cryo is doing. I'm going to give you a few examples, and then I'm going to talk a little bit about how we plan those things out to give you a picture. So at the central helium liquefier, some of the big items that we're going to be doing are we're going to be installing this new recovery compressor that we just got finished building. So this is, when we talk about recovery compressors, we're talking about something that's like a 150 horsepower compressor that we use to move gas around to our purifier systems. So we're going to be installing a new one of these. We're going to be performing preventative maintenance on 14 main compressors. Now what that means is these compressors range in horsepower from 600 all the way up to 2,500 horsepower. The sorts of things that get done during a PM can only happen when the machine is off. And they're things like checking thrust bearing tolerances, checking the alignments between this 2,500 horsepower motor and this compressor body right here, checking the bearings and alignments for the oil pumps. There's a lot of activities that have to happen to keep these machines running. And to give you kind of an idea of why we're so kind of neurotic about the maintenance on these, most industrial complexes get about 35 or 40,000 hours of runtime out of their compressors before they have to be rebuilt. We get over 70,000 because we're really careful about how we do it. We have very talented people that do the work on these machines and keep them running. So we're going to be doing that on 14 compressors this summer at CHL and ESR. We're also going to be doing a lot of maintenance on a bunch of vacuum systems, which, you know, everybody knows about vacuum systems, but we have a ton of them in cryogenics. And so when I say 4 systems, it's really 4 pairs of pumps that we're going to be doing work on, and these are the things that keep us running. We're also going to be rebuilding a large number of these pneumatic control valves. A lot of people don't know this, but we use a lot of valve systems in our stuff that, yes, sir.
Side question, John. Are the LCMS folks going to be in on any of this maintenance?
Yes, I will talk about that in just a minute, but thanks. But yeah, so we're going to be rebuilding these valves. These valves, we typically have to put soft goods in them and rebuild them about every 6 or 7 years to keep things working. If we have leaks through these valves when they're not supposed to be leaking, it makes it very difficult for the cryogenic systems to run. We're going to be performing maintenance on everybody's favorite, the magnetic bearing systems of the cold compressors, which we've had problems with in years past. If we don't do the proper maintenance on those electronics, then the systems won't run reliably. So we're going to be doing that. We're going to be doing maintenance on a lot of electrical systems in our areas, which is things like, cleaning, tightening terminals, checking to make sure that things are properly seated and stuff like that. And we're also going to be doing recertification on a bunch of our ASME relief valves. Within the cryo system, there's hundreds of relief valves, and some of those relief valves are part of a 5-year cycle that we have to look at these valves and recertify them every 5 years or so to remain in compliance. We're also going to be downstairs cutting out pieces of equipment to make room for a new 2 Kelvin cold box that we're building right now. And so this skid is an old skid that was used many years ago as part of the original CHL-1 installation. It's no longer used. We need this real estate, so we're going to be down there cutting it into pieces and removing it. At the in-station refrigerator, we're going to be doing sorts of things that sound really similar to the things that I just went through. It's going to be control systems and electrical systems PM. It's going to be doing PMs on the compressors that are down there, rebuilding pneumatic control valves. We've got a couple of valves in our turbine system that are leaking right now, so when we shut the plant off, some of the flow still flows through these valves into the turbine systems, which is something that we cannot tolerate. So we've got to fix those things. And we can only do that while the plant's off and warm. We're going to be replacing carbon in our carbon adsorbers out back. When you compress helium, you have to flood it with oil because the screw compressors can't get a bite onto the helium because it's such a small molecule. So we flood it with oil, and then you've got to get all of that oil back out because anything that goes into the cold box and gets cooled down to 4 Kelvin that's not helium will be a solid when it gets to those temperatures. So the carbon beds are our last line of defense. After we remove all of the oil, that helium goes through the carbon bed. It's an activated charcoal, and it gets out any remaining oil down to less than ppb levels, which is what we have to have because we run 24/7, 365 for many years at a time. So on top of that work, we are also this year coupled with facilities management. Now, Rusty's going to talk a lot more in depth about their work, but in CHL specifically and ESR specifically, they're going to be installing and removing large sections of scaffolding in these rooms so they can get up to the ceiling and do work that they need to do. They're going to be PMing electrical panels, circuit breakers, transformers. They're going to be installing a big UPS in our building, putting in new electrical panels, running conduit and wire between all of this stuff, and moving circuits between panels. They're going to be doing all of this stuff while we're trying to do the maintenance on our equipment. And so to that end, just one example is in the compressor room alone, and I borrowed this chart from Mary, but in the compressor room alone, at times we're going to have Carl Electric working in there on elevated platforms. We're going to have a scaffolding contractor in there putting scaffolding in, taking scaffolding out. We're going to have facilities management electrical people like Jason's group in there doing PM on equipment, on power panels and stuff. EES is going to be helping us out sometimes doing PM. And all of the things that I had described before that we're going to be in there doing. And so, how are we coordinating this? How are we resolving conflicts to try to keep this flow of work going? Because when the SAD was this big, we had a lot more time to spread things out. But now the SAD's this big, and so there's going to be times where people are working in the same room together, and you've got to figure out how to do that safely. And so what do? We do what we do best at JLab. We have lots of meetings, right? So we get groups together, and everybody lays out their work, and then you start trying to piece the puzzle together to find out where the interferences are. You don't worry so much about things that are not interferences, but you've got to worry about the places where people are going to be stepping over each other, working above each other. I need power on this panel because I'm doing some troubleshooting work and they want to cut the power off on this panel. And so we sat down at many meetings to look at these sorts of questions about coordinating timing, coordinating interfaces, coordinating the power outages. We eventually came up with a schedule, which you can't read, but we came up with a schedule where we list the work daily that's going to be going on. And these rows here are different groups of people. So it might be cryomechanical, cryo-electrical, facilities electrical, EES electrical. And we even put people's leave and vacation plans on there so that we could sort of see a picture of where are the problems going to show up. And then we started moving things around to try to make this work. And just small things started popping up. Like, for example, this is just one example. So at the CHL, on the one end of the building, if you want to pick something up heavy and move it to that wall, you can't do it without a crane. So you have to use a crane to lift it up and then boom it all the way in and set it down because the floor can't be driven on by a forklift. And so that's usually a pretty simple thing, except we realized that facilities management was going to install scaffolding about here. And so we had to do something because we needed to be able to get the C8 compressor in there so that we could do that work. And we also needed to be able to get the new air dryer into that same location. So it gave us the ability to flip work around and have things done before other things. So for example, this work has already been completed this past week, and it allows facilities to move forward with the work they need to do. So how are we going to resolve conflicts? Because something's going to happen. It's a guess. The schedule's a starting point. So how are things going to be worked out? Well, every day, we go to the MCC meetings and we work out things at the 8 o'clock. That's where kind of the big picture thing of what are people doing today, and it gives people kind of a second look at it. But we also, of course, in Cryo, we have a standing Tuesday meeting with all of our people that are in operations where we talk about things normally to do with operations, but we're going to use that meeting to also, we've invited other people, like facilities and operations, and we're going to talk about what happened during the previous week and what happens from that next week out. And it gives us a chance to make big decisions, like moving things around that, okay, well, this one didn't go so well, so it slid a couple of days, and now they're going to need more time, so we're going to have to move our work. That's kind of what's going to happen in this meeting, is it gives people a chance to identify issues that they didn't realize were there, and we try to work out solutions that will allow people to be successful, and hopefully this pattern will let us, minimize surprises and improve the coordination, and to, of course, above and beyond, make sure that everybody's working safely. And so, invariably, something's going to happen on a daily part of time. And when those daily things happen, our work coordinators are going to be the ones that are going to be doing that real low-level coordination work. And as long as they can solve the problem, they're going to shift work and do whatever they need to do. But if they can't solve it, then the people at the higher level will get involved and try to figure out a solution, or do we have to defer work, or does something get done at the end of the SAD rather than when we planned it, and those sorts of things. The goal is to try to get as many of those critical tasks done that we need to get done so that we can make sure our equipment runs reliably next year as possible, but without doing it in a way that anybody's going to get hurt, or we're going to compromise the machine safety as another point. So, do y'all have any questions? Because, basically this is the goals of the SAD for everybody, is to work safely, to try to get their critical work done, and to get the machine running reliably. Yes, sir. And I'm going to answer his question right in just a second. Parts of it will. There will be sections of it where, and mainly the scaffolding is going to be running around the outer edge of the room. There's one section where it's going to run through part of the room so that they can repair. Does everybody remember the multiple screws that got drilled through the conduits in the ceiling? They're going to fix those conduits during this summer down. Yeah.
A slip wrench can go from 30 feet up.
Oh, yeah. Yeah, definitely. Okay, so now to answer Bill's question. So, and I'll just keep it simple, but for about a year we've been telling LCLS2 about this down. And we've been working on them about the opportunities to come and learn as much as they can learn. They were going to come in February for a visit, but then some other things happened. They ended up having to cancel that. But we have commitment from a team that they are coming here on Monday. And they're going to be here Monday for an indeterminate amount of time. What we're going to do is hand them notebooks, and we're going to split them up and put them with different teams of our people that are going to be doing the jobs they're going to be doing a few years from now. And their job is to, when we finish the down, the only stipulation I gave to my people was, I want them to go home very tired and with a notebook very full of information so that they can start thinking about how they're going to develop their operations group, which doesn't currently really exist at LCLS2 right now. Yeah, they will. Any other questions? Okay, thank you.
My name is Steve Suring, and I work in Accelerator Operations. Thank you. If there are no more questions, I'll sit down at that high note. Okay, for those of you that are fairly new to the organization, welcome and all of that. We're glad to have you here. And as has been outlined by Dave and Jonathan, Mary, and the like, it's a busy time that we're looking forward to. You've seen screenshots of this whiteboard thing, and the morning meeting at 8 o'clock at the MCC is where we do the day-to-day coordination and try to identify problems as a day is getting ready to develop. We also have as a tool the SAD calendar, SAD Scheduled Accelerator Down. And this is available. I encourage you to find the laser, whoops. Okay. I encourage me to find a different laser pointer. And, all of these slides are going to be posted. If you were interested in what's happening on a day-to-day basis, you can take a look. And as was mentioned, that on Sunday the 6th at 6 a.m. we stop physics, okay? But the SAD gets real involved then for the next about 2.5 months. And we try to list major tasks. Each of these tasks has a hyperlink to the Atlas system. And again, if you're unfamiliar with that, ask somebody who's been here for a while. And you'll be able to drill down and look at documentation and safety considerations and things of that nature. Okay? I've got about 5 slides. Within Accelerator, we have the source and injector group. These are their major tasks. Bubble chamber installation with a run on the 2nd week, high voltage tank upgrade. a new cathode electrode, and then we're going to be commissioning portions of the new injector, but then being at the standard energy that we're at right now, 130 kV. Each slide is going to have an area where what work planning has been going on, and then concerns at least that have come to mind with regard to the execution of work. So it's looking at work planning from a little bit different point of view. So in order to move big things around, you've got material movement, whether it's forklift or cranes, and again, as has been pointed out, we've got outside users that get involved when we have experiments that are developed apart from JLab staff. And also, just be aware of your work conditions. In the injector itself, it's a fairly tight work area, and again, we've got multiple groups. Within the SRF division, cryo modules are coming in and out of the Linacs, helium processing, cryocycles, vacuum pumps that we're going to be adding to help augment insulating vacuum, and testing on off shifts. So we'll be locking up the tunnel on swings and then days and swings on weekends. So again, work planning, it's material movement and radiation considerations, as David outlined. And then with regard to execution of work, we're focusing on safety. But if you're doing it really well, your stuff is going to be clean, we're going to have a better product, you're going to be more aware of your surroundings. So cleanliness is really important to anything going on with beamline vacuum. Again, as Jonathan indicated, we've got a whole lot of U-tubes that need coordination, and that's not just which tubes come in and out, but how do we do this so that we don't step on each other? And then, again, with the lockups. Third group within accelerator operations is CASA. The reason this is being shown right now is that we need to be documenting changes. And if it's something that is on the beam line or affecting the beam line, that needs to go into the CED. If you're saying, gee, I've never heard of that, that's okay. I'll say many, if not most people, have very little interface with the CED. But if you do, we need to be sure that changes get in there, magnet changes and things of that nature. And the other point, as we've been driving home, is that there is a limited time for the shutdown. And so if you're documenting things well, either in the E-log or the E-log, we'll have a real good opportunity then to know what needs to be looked at before we try to turn the machine back on. Accelerator operations are the folks that run the machine, the group that I have, which is called operability, and we're responsible for overall SAD coordination. We try to do it with real simple graphs and things to look at. Physics ends on the 6th, as we said, and we start physics on the 22nd, but in between that, we have all of the different cryo reconfiguration times where we're bouncing between 2 and 4 Kelvin. We've got an experiment. We've got injector testing almost the entire time. And then near the end of it, we've got to put a standard PSS certification. That takes 2 weeks, swing shifts. Jerry and his group go into hot checkout, and then we get busy. So what we're interested in from operations, as we all are, is the safety, the effectiveness of your effort. Let's do it well. And then we want to make sure that our machine performance can support physics when we come back in. Folks say this different way. I like to think of it as, collective problem solving. This is a remarkable group of people that we have the pleasure of working with, and I'm absolutely convinced that together, if we can build this machine, we can break this machine, and after it's broken, then we can fix it. We have proven processes that we want to make sure that we stay with the conditions, but there is going to have to be flexibility and creativity. Update your Atlas tasks. Get them submitted. If you still have work that you're planning, great. That's what we want to do. I encourage you to partner with your ES and H folks before the work starts, okay? If you have any questions at all, call EH&S and say, look, will you look at this? For those that don't know it, EH&S looks at every Atlas task that comes through, okay? They're reviewing all the work plans, as are a couple of other people. And as has been noted before, think through your work, okay? Give me a shout. Give my deputy, Randy Michaud, a shout if you have any questions. And thank you. Anything come to mind right off the bat? Hey, Anthony.
I just want to make a plug for the hot checkout tool, also the CED, as Steve's talking about, has nice hot checkout. As we're doing work and we're pulling elements out and doing repairs and everything that goes over a game, we should be downgraded, and that's another tool that we use to make sure we're checking the right things when we get the machine back up. So there is a tie there.
Great, thank you, Anthony. I neglected that. Anything else? Okay, thank you.
Good morning. Rusty Sprouse from Facilities. I wanted to just start off that our contractors take the same training that you do to go in the same areas. On top of that, we add additional training, and we also require them to have activity hazard analysis, which are kind of like your task hazard analysis. And many of the contractors also have to have a safety plan, which at least meets our requirements. So we'll be following through those things. Bob Sperlaza has pulled a lot of information together, and I was going to show you our schedule, but you couldn't read it even if it's blown up. There's 206 different groupings of activities throughout the SAD, and they're scheduled on a daily basis. I think Bob's going to work with Steve at getting it on the wall in the MCC so that we can all see what's going on, but I think we've gone far more, although we've always planned our activities through Steve and the group. I think, as Jonathan indicated, with his, we've just gone that much further this year just because of the compressed schedule. And I don't have the flipper. Got it. Our major activities are here. I'm not going to go through everything, although it will seem like it, and we'll just kind of hit some of the high points. The most intrusive thing we're going to be doing this year is literally turning off every transformer on the accelerator site, testing the oil, and running some electrical tests on it. So you all remember the CHL1 transformers that literally blew up. The reason is that the paper insulation inside the transformer basically degraded. It's close to 30 years old, and a life of a transformer is 30 years. And while we've been changing out a few of them over the last few years, we aren't that far through it. And so we'll be turning all those off. We're going to start work at 5 o'clock at night and work till about 3:30 in the morning. And I'll be going through the buildings and what areas that are going to be affected. We're also going to be looking at panels. We're also going to be exercising breakers. Jonathan and I have talked several times. He has breakers he's afraid to touch because he's afraid they won't reset. And so we'll be going through that process. I know in some of the halls we're actually sending some of the breakers out to have them tested in a shop to make sure that they're functioning. Okay, so the first one is we're going to try on CBAF Center first on the 8th. But it will affect the EEL, the TED building, but most importantly, and it's going to affect a lot of you people here, is we're bringing down the chilled water plant, which means that anything that has cooling, you need to turn it off or it's going to overheat. And that's in all the accelerator service buildings. We're also going to take down the data center. Core computing will stay up. Again, we need everybody out of the building. We'll be doing that. We broke these up so they wouldn't be together. The 17th of May is the next, the group. I'd like to go back on the 8th. We are sending out through communications an all-site, or at least in the weekly briefs, more detail exactly what's going to be affected, just so everybody knows. Again, so we've broken it up. We're going through June, different sections. The only thing not affected is CHL2 and Hall D cryo plant. Everything else is going to be affected. We're also doing work on the 40 MVA substation, some maintenance, but we're also going to improve the reliability. We're going to connect it so that we can switch CHL between the two substations. And so that work will be going on. And that's going to be the 7th through the May 19th. We're going to have power up and down a couple of times. There'll be short durations. We're going to move most of the load on the 33, so that shouldn't affect most of you. Cooling towers, this is things we do every year with cleaning the cells, upgrading some sensors. We got some couplers that look like they're failing, so we're going to literally be changing the couplings out on every cooling tower we have. And again, we'll be able to keep the water flowing, so that shouldn't be an issue. We're doing some underground chill water piping. That's going to affect very limited buildings indicated here. And that's just to tighten up some of those flanges. CHL1, this doesn't really say the true picture of all the work going on there. The key is we're putting redundant power into the CHL controls. In the past, when we've had bumps, the controls actually got knocked off and really caused issue. The UPS comes from the computer center second floor here. We moved it down so that the controls will be at least stable. We're doing a lot of LCW work. We've had some problem with some deoxygenation capacity and some water makeup, so we're doing some improvements on those. We do have a bypass loop, so that shouldn't you shouldn't notice the majority of that work. We're looking at improving some of our sensors also for that system. I know we're pushing that system fairly hard with, in fact, we're bumping up against its capacity, so we're trying to get a little bit extra out of it, and then calibrating some controls. We've already talked about the electrical systems on north and south access. We're doing some elevator repair work on the 7th. Now, these things, we're trying to work around plans. This is the material elevator going down. But again, I think we can work around. There's not going to be much impact. And then we're dealing some groundwater pumps. Service buildings, standard array of things. Because of like what Dave was talking about, we need to coordinate some of the filter issues with RADCON. And so the potable water system, I was talking to Steve earlier. Yesterday I would have told you we're going to do some in June and May, and then I found out we had a little bump. And so we're working through those scheduling issues, and we'll be just touching base with Steve. I think the majority of the work will be done in June, and that's where I think most of it is going to be anyway. But what this is going to do is literally going to cut water off to these buildings as we do. We have saddle taps. When they built the accelerator, they literally just clamped on a T to the main water supply system. Unfortunately, it was galvanized instead of stainless. And with our acidic soil, it basically just ate it up. Last year, we had a leak behind the south access where we identified this problem. So we probably have 30 different saddle taps, and we're starting that process of replacing those. We're also installing some new valves in the water distribution system. Right now, if there is a leak, we aren't able to, we have to turn off more water than we really want to. So putting some isolation valves in is going to help that issue. And then the tunnel and the halls. We had a few leaks in the fire sprinkler system. We think it might be some internal corrosion, so we're going to be doing that inspection of the various zones on that. Depending on what we find, we might end up having to replace some sprinkler piping. We have some dehumidifiers right now. A number of them aren't functioning. We're going to be able to replace 2. the schedule just wouldn't allow for. We have the materials, but the last two would have required breaking the beam line, and it just gets very complicated after that. So we're going to reschedule that either in the winter or at another time through Steve. So we've had trouble with the fire detection components, with the radiation damage. We're going to repair those. We actually are in the process of designing a new system. It's a linear system that won't have any electronics in the hall. The concern here is if we have VESTA and we have the heat detectors, and if we lose both, then we can't run the accelerator. So we're trying to make sure that we strengthen that system. We've worked real close with the halls on doing a lot of their electrical work also, and those are the breakers I know we're sending out. We're also doing some work in the beam dumps with the controls, and then so we had some air supply monitoring and alarming that we'll be able to get accomplished during this down. And I believe that's it. And so unless there's any questions, please call us if there are. Again, Bob will be going to the 8 o'clock meeting every day. We're going to try to be looking at this a week ahead. Looking at it the day of is more complicated for us since we have outside contractors doing a lot of our work. But again, we understand there is going to be change. We're going to work with it just like we did for the UIM project when we were doing all the electrical work. That worked very well, and so I think it will work out well here too. Any questions? Thank you.
So a friend of mine, or for people that don't know, I'm Ed Foltz. I'm the DSO of physics. A friend of mine sent me this picture when he found out that I was a blacksmith and wanted to know if it was me. I told him no, it had too much hair. See how to work this thing. So starting with Hall D, I appreciate the Hall sending me this information because a lot of it I don't even understand. But there is a lot of work going on in all the halls for open house presentations. In Hall D, the install and test the first detector of the DIRC detector. I had to ask somebody what it meant. Oops, wrong button. Where is it? There it is. Go back again. So in addition to the DIRC, they're going to design, fab, and install the ComCal test, repair CDC leak, repair BCal cooling system, power supply maintenance and checkout, replace the optical fibers on the microscope, goniometer maintenance, detector gas system improvements, and routine maintenance on the crowd target. So they're going to be busy and they won't be going to the beach. In Hall C, the warm up and cool down both spectrometers because of the ESR down, remove our routine maintenance on the crowd target, upgrade the molar power supply power feed, magnet power supply maintenance, JT valve rebuilds, pump and cryogenic vacuum systems, detector maintenance, spectrometer motion system upgrade, shield house door operating system upgrade, sweeper magnet assembly and test, and hopefully facility is going to get to the groundwater leak repair. But Walter's not going to the mountains. In Hall B, warm up and cool down magnets, work to seal the leaks in the low threshold shrink off detectors, say that 3 times fast. Separate the Silicon Vertex tracker and Micromegas Vertex trackers so they can be worked on outside of the hall. And in Hall A, they're going to be warm up and cool down both spectrometers, clean up the vacuum systems, perform maintenance on the vacuum pumps, perform maintenance on the cryogenic system, swap out a power supply for the right Q1 magnet, infrastructure work for the SPS power supply, install electronics and cables needed for the right HRS bogey system, move the electronics for the left HRS bogey system to the shield hut, test magnetic shielding for the exit beam pipe, and modify the apex septum magnet. And work being done by others in the hall is to package and ship the tritium cell, final as-found surveys, repair main air handling unit, and remove and modify a section of the beam pipe on the exit side. Tritium work in the hall. They're going to warm the target on the 6th, but the hall remains in tritium mode until the cell is secured. On the 15th, they expect to secure the cell and put it in the tritium storage vessel. They need SSO support and RADCON support for that. And once it's secured, the hull drops to normal mode and you can open all the doors. They'll need a post-run survey for the target. And then on the 18th of June, they are going to transfer the tritium cell from the storage vessel to the bulk tritium shipping package and send it back to Savannah River. They'll need SSO and RADCON support for that. And then in August, they reverse it and get a new cell back from Savannah River. They'll need SSO and RADCON support for that. Well, we don't have a date for that yet. At a to be determined time, they will install a new cell in the target. And they'll need SSO and RADCON support for that. At that time, the call will go back to tritium mode, and tritium training will be required to enter the hall. In summary, aren't you glad? With all the work you have to do, please communicate. Look out for your coworkers. Think about what you're doing. And that's an easy statement to say, but you know, how many times have you stepped down a ladder and missed the last rung, or knocked a tool off of what you were working on? Think about what you're doing at the time. Write task lists and write them as soon as you can to let the hall coordinators know that work is coming. Read and follow OSPs, get and follow work permits. And if you have any questions at all, contact the work coordinators as soon as you can. They are the guys that are supposed to keep everything together in the halls, and they are the ones that know what's going on. And on this down especially, don't be afraid to push back. And that's what I have. Any questions? Thanks.
Well, I'm Kevin Jordan. I was tasked last fall to convert the free electron laser, LERF, however you want to call it, to a test facility for LCLS-2 cryo modules. So it's kind of twofold. In one respect, it relieves pressure on the CMTF for the backlog of module testing. And additionally, it replicates the L1 for the LCLS upgrade. So it's two LCLS cryo modules, all the low-level RF, the high-power solid-state amplifiers, the cryogenic controls, vacuum controls, you know, the whole ball of wax. So this is before down in the vault, you know, so the modules are still down there. There's a big empty hallway there. And that's kind of what it looks like now. We've moved to first, we've taken SL21 and F100 out to install in CBAF. Steve goes over those activities. There's 1,400 feet of new waveguide installed. We've got upstairs, this is the before shot upstairs. You can see the tape layout on the floor. And now we've got all of the Slack provided hardware installed, well, in the gallery upstairs. Okay, so that's a number of racks, solid-state amplifiers. All the waveguide is complete upstairs. What we've got to do left that has to fit into the schedule, so Steve has the overall schedule for the shutdown. My activities are second to CBAF activities on the SAD, especially because it's compressed. The main things I have is this cryocan and this transfer line. Okay, so I'm kind of at the transfer line delivers in late May, the cryocan in late July. We were originally scheduled to cool down and test 2 cryo modules in July timeframe, but that's looking, it's looking a little, probably won't happen until later. Oops. So one of the things we want to do is, right, get this, what do I do now? All right. So one of the things we want to do is, the transfer line in the FEL is warm right now, and the quarter cryo module and the full cryo module is warm as well. All right, there we go. So we want to cool down. Yeah, all right. I'll leave it right there. So we want to cool down the transfer line so that we can fit in between the CHL reconfigurations, and we'll cool down the cryo modules when we have an opportunistic time when there's a CHL trip or we combine, you know, we don't want to interfere with the physics run in the fall, but this is a funded activity and we need to get them cold at some point. The slack loaner equipment is all here. The low-level RF racks are here, solid-state amplifiers. We've set up a LCLS network so that a lot of the software development, all of the code that will be used to turn slack on in a year or 2 from now will be developed at our facility here and mostly remotely. So Wes has set up 2-factor access for LCLS net out in the service out in the LERF building. And we have our own servers, we have PCs to control PLC software, and all those activities. Folks from Slack will be doing a lot of the work either here or remotely. So next Thursday, some of the guys are going to show up and they're going to actually start landing cables into the cryo racks and getting this set up for PLC code. We've got inside of each of the cryo modules is a superconducting quadrupole and a horizontal and vertical trim. So we've got magnet control racks, and we got all the cryo racks. We've got about 250 cables to be installed. So my main activities are installing the transfer line, which is a field fit weld. We're actually using the existing U-tubes, and we'll have a new transfer line that takes the cryogens into the middle of the vault. And then we have the cryo end can that delivers the cryogens to the LCLS cryo modules. So again, that's going to be in July, and it's right at the, you know, we're just going to probably miss the window for the CHL reconfiguration. So that's the last of the lift going on. The documentation on everything is at the wiki.jlab.org/LERF. We coordinate at Wednesday morning, 11 o'clock for the weekly coordination meeting for the activities in the LERF. All of the, you know, I rely on the engineering division and the rest of the accelerator division folks to do the work when they have time available. And that's it. Any questions? Okay. Good luck on that.
See if I can make this thing work. Hey, look at that. I wanted to close by coming back around to a couple of the themes that Mary spoke to right at the beginning, because I think they are really important, very important, particularly for the situation that we're facing of a shortened down, a lot of complex activities, a lot of work groups simultaneously in the same physical spaces, a lot of coordination between groups and regions and staff and subcontractors and so on. Mary showed a chart similar to this, and I think it's really important when we sort of think in advance
in planning work, what are the things that can go wrong, having a questioning attitude. It's looking out for decisions that we make, things we do that line up in a way that can lead to something bad happening. And this is a common way of talking about this. But when you go back and take a look here at Jefferson Lab, at other labs, high-profile failures out in industry, there is an amazing level of commonality between those sort of events, and the way that people who study this stuff think about it is in terms of this Swiss cheese model. So, what you want to try to avoid is lining up all the little holes in the Swiss cheese where you can provide a trajectory that leads straight to something bad happening. And, it's important to realize that there are a lot of elements that when you stand back and look at a time when something bad has happened, goes all the way back to, in some cases, executive decisions that maybe we make as a laboratory, management decisions, those feed into it. We've already made a decision now that we're cutting back on the length of the shutdown. The expectation is that we're not doing all the work in half the time, but that work has gotten deferred as a result of that. We've already heard we're going to have folks coming in working odd hours, working off hours. Those people show up, maybe being tired or at the end of the shift or quite tired and ready to go home. So there are physiological, things going on there. There's the sometimes motivation to cut corners or to do a workaround. Maybe there's a procedure or a process that as written isn't right, so we've always sort of worked around it. Those things feed into it. And then there's, the last line of defense, whether it's PPE or engineered safety system or what have you, that, somehow there's an issue there, and one can lead to a very, bad outcome. So it's just good to think about this. I think when there's complex work activities going on, are we really, making the right decisions early on? Are we not setting folks up to end up on one of these bad trajectories? There are a lot of issues that can, feed into, bad days. Familiarity, hey, I've been doing this for 20, 25, 30 years. I know how it's going. Repetition, again, repeated. I've done this before. I'm confident, maybe overconfident. Groupthink, sometimes we get together and, we launch off and make a decision, and we're sort of all in that groupthink mode. So, a questioning attitude there. Stress, showing up at unusual times, working late, recognizing the stress that odd shifts, has back at home in some cases. Reliance on authority. Well, somebody told me to do it. I knew it was a dumb idea, but, we went off and did it anyway. So, the point is thinking, questioning yourselves, questioning what you're hearing, questioning if something doesn't seem right, doesn't feel right. It's very important to stop, question, take a breath, really think through what's happening, particularly in events where you see yourself starting to head down one of these trajectories. Situational awareness is also a really important theme, and is a sort of theme in a lot of accidents that have been taking place around the labs generally. Is the situation around you. In the workplace, people work, someone mentioned wrenches dropping 30 feet from scaffolding. That's an example of situational awareness. You're walking in to do work. You're observing the situation around you. I need a hard hat. It says to put a hard hat on. So, just being very cognizant and mindful of the work that's going on, that's going on around, I think is extremely important. So I wanted to sort of hit on that theme again. Takeaway really is there's a lot of work that's been planned for this SAD. A lot of work going on. It's great to see the upfront planning. That's really important. We all recognize the plans will evolve as the SAD evolves. That's a natural part of life, and I'm counting on management and the work groups to plan, replan, keep the plan up to date, communicate the plan. Requires a lot of communication, talking to each other, having a questioning attitude, very important. If something doesn't seem right, something doesn't smell right, doesn't feel right, you get a bad feeling in your gut, that's the time to question it. Raise your concerns. We want to be better all the time. It's hard to be better if when bad things happen, we don't talk about them openly and learn from them. Or if we're putting undue, unrealistic expectations, the time to bring that up isn't afterwards, it's as it's happening, and bring those concerns up. Everyone has the authority to stop work if what you're seeing or doing just doesn't look right, makes you feel uncomfortable, gives you a bad feeling in the pit of your stomach. That's the time to just stop, take a break, and sit back and think about it more calmly. I'm confident that your engagement, your attention is going to lead to a very successful SAD. There's a lot of important work that has been planned, a lot of important work that is very important for improving CBAF, improving the facility, improving the reliability, and ultimately getting science out, which is why we're here. So this down period is a very important one, but at the same time, we're not going to let schedule override safety. So safety is paramount. We're here to get our work done safely, and that's certainly the expectation that we have. So with that, maybe I'll hand it back to, how does this work? It's my first one of these. Does Mary field questions and hand them out? Is that what you want to do?
Are there any questions? Tina?
Yeah, I'd like to just say, I can see there's been a lot of preparation and planning going into this SAD. You'll consider doing that for this upcoming hurricane season with your work as well as your family, so you never know. Had really bad, hurricane season last year, we'll tell what's coming at us, but it does start June 1st, goes all the way to November 30th. So just remember to take care of your home, family and stuff during the season. We're about ready to come on.
Thanks, Tina. Anybody else? Okay, well, thank you all. If you have not badged in, swiped your badge, please do so we can get an accounting of you all.